week. So I think in the last class we have discussed work energy theorem and non-conservative forces vagera. So I wanted to focus on, we have also discussed conservation laws of energy. I wanted to focus on a few topics, mixed topics, conservation of momentum. There are a couple of questions related to that. Conservation of momentum, maybe collisions along with it. And there is a topic of simple harmonic motion. If I get time, I will discuss it. Now, usually what happens is that simple harmonic motion is discussed very much in detail in your subject of wave oscillations and optics. So wave oscillation optics वाले जो subject में wave oscillation वाले subject में काफ़ी detail में discuss किया रहता है ये वाला topic, but the questions can range from wave oscillation related questions as well as mechanics related questions. There are some mechanics related questions as well. So I'm going to discuss the topic in very brief manner. Okay, a much more detailed discussion will happen in the wave optics classes, but in mechanics classes I'm going to discuss it very briefly. Okay, now I don't know if I have mentioned conservation of momentum in detail. Linear momentum. So let me just mention it to you and then see if we can do questions related to that. Now मुझे पता है कि आप लोगों को लग रहा होगा that this is a very easy topic and I mean you should not really be bothered by this particular topic, but let me tell you that there are certain kinds of questions which are very hard, very hard. I mean even if you are familiar with the conservation of momentum principle. So let me give you the first definition first, and then we'll look at those kinds of questions. So what essentially happens is that if there is a certain kind of a system which is not experiencing any external force, okay, if a certain kind of a system is not experiencing any external force, that the overall linear momentum of that particular system is going to remain a constant of motion. So that is known as a conservation of linear momentum. And because the force equation is a vector equation, that means the force equation is equally applicable in all three independent axes, x, y, z axes. Therefore, the conservation of linear momentum is equally applicable independently along the x, y, and z axes. Okay. So when there are no external forces acting on a particle or a system of particles, the total linear momentum along that direction is a constant of motion. Okay, so what we can say is that for a point mass, we know that the net force is equal to dp upon dt. That is a Newton's second law. If F net is equal to 0, then automatically the momentum of that point mass is a constant of motion. Okay. For a system of particles, we have to take a summation. For a system of particles, if F net is equal to 0, then the summation of all the momenta for all the particles is a constant of motion. Okay. So if you have a point mass particle, then if the point mass particle is not experiencing any force, then the linear momenta of the point mass particle will be a constant of motion as the system evolves. And if you have a system of particles, then the system of particles, if the system overall is unaffected by any external force, then the summation of the linear momenta of the system of particles will be a constant of motion. Okay? So that is not to say that the individual particles within the system will have constant momentum. No, the individual particles may experience exchange of momenta, but the system as a whole is going to have constant momentum. All right. Now, ये तो दोनों चीजें हो गई, एक हो गया पॉइंट मास के लिए, दूसरा हो गया सिस्टम ऑफ पार्टिकल्स के लिए. Now there is one more thing that is very very important and sometimes it is kind of neglected, is that ये जो equation है, it is a vector equation if you look at it, you know, because you have this arrow here. Vector equation का मतलब क्या होता है, that you can always write the vector in terms of the x, y, z coordinate system. So if we look at in vector notation, F-net is equal to dp by dt means that fx I cap plus fy j cap plus fz k cap is equal to dpx upon dt I cap plus dpy upon dt j cap plus dpz upon dt k cap. Now these are all independent equations, means I can write them separately. That is, I can say fx is equal to dpx upon dt. I can say fy is equal to dpy upon dt. I can say fz is equal to dpz upon dt. So it simply means that it is possible that the force along a certain direction is non-zero, but along a perpendicular direction is zero. In that kind of a situation, the momenta along the first direction will be not a constant of motion, but along the second direction will be a constant of motion. Okay, so for example, fx is related to dpx upon dt. तो मैं अगर आपको बोलूं that if fx is equal to 0, can I conclude that px is a constant of motion? Yes or no? बताइए. Even if fy is not a constant of motion, that means if fy is not equal to 0, then py is not a constant of motion. I can do the same thing for the others. Fz is equal to dpz upon dt, which means that if fz is equal to 0, then pz is equal to constant of motion. यहाँ पे ध्यान रखने वाली बात क्या है, is that system के अंदर force है. Why? Because fy is non-zero. So the system is experiencing some force. But if we resolve the forces along the x, y, and z axis, it turns out that there is no force along the x axis, there is no force along the y axis, sorry, z axis. As a result, px and pz are going to be constant of motion, but py is not going to be a constant of motion. Is this something that you're understanding? बताइए, ये समझ में आ गया? Yes or no, guys?
Yes.
Yeah. So it is possible that there is a system which has some net force, but that force is only along a very specific direction. In that kind of a scenario, the momentum will not be conserved in that specific direction, but it will be conserved in the perpendicular directions. All right. So you have to be careful about that. So as far as the conceptual understanding is concerned, this is it. As far as conservation of linear momentum is concerned, it's a very simple concept. You don't, there's not too much complicated theory around it, but it becomes a very important principle, especially in problems involving collisions, in problems involving maybe something that has to do with, conservation laws, conservation of energy, conservation of momentum, वगैरह वगैरह. And depending upon the question, it might be a easy question as well as a little difficult question. So questions karenge to we can see how we can apply this particular concept. So let me give you a question. And this is a question from TIFR, and not that easy question. I mean, it is actually easy, but conceptually it's easy, but I'm not sure whether you will be able to connect the dots. But एक बार देखते हैं, and let's see. All right, so this is a question from TIFR. Okay, a region of space is divided into two parts by a plane P. So on one hand, you have this region, let's suppose region 1. Okay, and let's suppose you have another region. So these are two regions. They have been divided into essentially two parts by the plane P. Okay, a particle of mass m. So this is a particle of mass m, passes from region 1 to region 2. So it goes from region 1. So this is the डायग्राम क्लियर नहीं है तो मैं थोड़ा सा क्लियर कर दे रहा हूँ रीजन 1 to region 2. This is the direction of its motion. Okay, where it has a speed v1. So region 1 में it has a speed of v1 and it has a speed v2 in region 2. There is a constant potential u1 and u2 in region 1 and region 2 respectively. Let T1 be the kinetic energy of the particle in region 1. If the trajectory of the particle is inclined to the normal by the plane P, so ये trajectory आपका ये normal है. This is theta 1, this is theta 2. Then what is the ratio of sine theta 1 upon sine theta 2? Question is not very lengthy, not very complicated, but it requires a good understanding of all the parameters involved. Now of course मैंने ये question इस topic के अंदर रखा है तो somehow that will be relevant. तो एक बार try कीजिए, take 3 minutes and think about it if you can get the answer. What is the ratio of sine theta 1 upon sine theta 2? I hope that you are maintaining your sheets, or I should say formula sheets and notebooks for taking notes as well as problem solving. So you can try this question. It's a particle moving from one region to another region. Both regions have constant potential u1 and u2 respectively. Particle has different velocities in both the regions. Angle of incidence and the angle of refraction for the particle is different, theta 1 and theta 2. So what is going to be sine theta 1 upon sine theta 2? Try. Kashan, your answer is correct. All right, let me start. Okay, so आपके पास दो रीजन है that has different potentials. Particle is going from one region to the other. All right, what concept can we use here? Anybody? What is the concept that we can use here to solve this problem? Particle goes from
vertical direction में momentum conserve कर सकते हैं.
okay.
Vertical direction. Also conservation of energy.
Yes. Why not in the horizontal direction?
Sir, region 1 और region 2 horizontal direction में ही divided.
Potential अलग अलग है तो उसका मीनिंग क्या होगा? Horizontal direction में
फोर्स भी अलग अलग होगा दोनों रीजन में.
फोर्स अलग अलग नहीं, बट फोर्स ग्रेडियंट होगा, मतलब पोटेंशियल ग्रेडियंट की वजह से फोर्स होगा. ओके, ठीक है. सो यू हैव अंडरस्टूड द कॉन्सेप्ट perfectly. So we can use two different concepts in this particular problem. One is the concept of conservation of energy, which is kind of very obvious here. You don't have to like u1 plus t1 is equal to u2 plus t2. Okay, perfectly fine. But there is another concept that we can use here, which is slightly tricky, but once you know it, you will not forget it anymore. What is that? Is that if you have region 1 at constant potential u1 and region 2 at constant potential u2, then how is potential related to force? क्या होता है रिलेशनशिप फोर्स और पोटेंशियल का? F is equal to minus du upon dr. R could be x or y, whatever it is. So force exists along the negative potential gradient. All right, this is very important. Force is the negative potential gradient along a certain direction. Along a certain direction. Certain direction. For example, if I move something, मतलब मेरे रूम के अंदर, if I move something vertically, there is a force in the vertical direction, gravitational force. इसलिए वहाँ पे potential difference है. But if I move something in my room horizontally from point A to point B having constant height, उस direction में कोई force नहीं है, इसलिए potential is a constant. ठीक है? So force और potential का जो relationship है, it is given by this particular expression. Vivek, correct answer. Swarnava, it is not correct. Check again. So whenever there is a potential gradient along a certain direction, there is going to be a force. And whenever there is no potential gradient along a certain direction, there is going to be no force. So what I can say is that let's suppose that the horizontal direction is the x-axis and the vertical direction is the y-axis. अब मुझे बताइए, is there a potential gradient along the x-axis? Is there a potential gradient along the x-axis?
Yes sir.
मतलब आप अगर इस डायरेक्शन में जाओगे तो does the potential change as you move in this particular direction? Yes,
sir.
it does. So that means fx is non-zero. Okay, if fx is non-zero, it simply means that px is not a constant of motion. Momentum changes. But now tell me, along y-axis, is there a potential gradient along the y-axis? कहीं पे भी आप चूज करो, if you move along the y-axis, would the potential change if you move along the y-axis?
See, if I choose the boundary, means the boundary dividing u and u, then
it's up to you whether you choose a number. It is a very precise boundary. So if the boundary exists, if I define that u2 exists from x is equal to 0 to x is equal to infinity, and u1 exists for x less than 0. So you choose the point. You can choose x. No matter what x you choose, as you move vertically upwards, would the potential change? So if you choose
No,
x
sir.
is equal to 0, potential will always be u2. If you take x is equal to, let's suppose, something like minus 0.99, potential will always be u1. Are you understanding? It doesn't matter. You can choose the location, but as long as you keep moving vertically upwards, pure vertically upwards, then there is no potential gradient. Therefore, Fy is equal to 0, and hence Py is a constant of motion. Py is conserved even though Px is not. ये लॉजिक समझ में आया कि नहीं बताइए?
Yes, sir.
Okay. See, it is an easy question once you understand this logic, and once you understand this logic, you will not forget it again. Anytime you have a scenario in which there is a clear demarcation of the potential regions, then one thing becomes automatically obvious, that in the direction in which the potential is changing, there is a force perpendicular to the direction in which the potential is changing. There is zero force. Therefore, in the perpendicular direction, momentum component is going to be conserved. That gives us an additional equation that I can use in my problem. So if I say Py is constant, okay, so can you tell me what is Py in region 1 and what is Py in region 2? बताइए. What is Py in region 1 for the particle?
V1 cos sin theta.
V1 sin theta.
M V1 sin theta 1 is the y component of momentum in region 1, and M V2 sin theta 2 is the y component of momentum in region number 2. That's it. So यहाँ पे m and m gets cancelled and we are left with sin theta 1 upon sin theta 2 is equal to V2 upon V1. Now, if you look at the options, even though they are asking what is sin theta 1 upon sin theta 2, they are not really asking in terms of V2 and V1. They are asking in terms of kinetic and potential energy. So I'll have to convert this into kinetic and potential energy. What can I do? I can say, okay, V2 upon V1 में क्या कर सकता हूँ? V2 upon V1 square कर लेते हैं, square root लगा देते हैं. Okay, so this is equal to square root of half m V2 square upon, this is just mathematical substitutions at this point. Okay, so what is half m V2 square? That is the kinetic energy at region 2. Half m V1 square is kinetic energy at region 1. So kinetic energy को कभी हम KE भी लिखते हैं और T भी लिखते हैं. They are both representative of kinetic energy. ठीक है? Usually in Newtonian mechanics, kinetic energy is written as KE. If you look at Kepler, they will write kinetic energy as KE. But when you study classical mechanics, kinetic energy is usually represented as T. It doesn't really make much of a difference. Depending upon textbook, depending upon what you're studying, they may use different expressions. So T2 upon T1. But we also know conservation of energy. Conservation of energy says what? T1 plus U1 is equal to T2 plus U2, right? Total energy T1 plus U1 is equal to T2 plus U2. So this can be substituted as T2 is equal to T1 plus U1 minus U2, which if I substitute here, this becomes T2 is equal to T1 plus U1 minus U2 divided by T1 square root. This gives me 1 plus U1 minus U2 upon T1 square root. That's it. This is your answer. 1 plus U1 minus U2 upon T1. Answer is option number F. So this is a TIFR level question. Mathematical calculations are Very simple. Concept is just a little subtle concept, nothing else. If you understand conservation of momentum, if you understand that momentum can be conserved independently along different axes, depending upon whether that force has a component along that axis, if you know that the force is only in the direction of the potential gradient, then you can combine those concepts to solve questions like this. Bataiye, is this question clear to everybody? Everybody, is it clear? Vidyut, correct answer. Swarnava, is it clear?
Yes, sir.
See, questions like these, they can only, I mean, you can only get good at it by solving them. That's it, nothing else. Without solving, becomes difficult. Let me give you one more question. All right, let us move. ये तो I think question हो जाएगा. इस तरह का एक और question मैं homework में दे दूंगा. You please try in the homework. So let us move forward to a slightly different question. Questions which are a little bit more common in JAM, which is related to collisions. Okay, so whenever you're solving problems of collisions, थोड़ा सा मैंने करा भी है. If you remember when we discussed kinematics, we were discussing coefficient of restitution. We were talking about collisions there also. So, you know, collision related problems are everywhere in kinematics, in conservation laws, in rotation. So it's kind of scattered around, and I'll try to incorporate them whenever it is possible. So वहाँ पे भी हमने discuss करा था. यहाँ पे एक बार फिर से discuss कर लेते हैं. Because these kinds of questions are slightly common in JAM, okay? Less common in TIFR, JEST, more common in JAM. In fact, every year you will find some collision related problem. And most of them can be solved by, you know, conservation laws of energy, conservation laws of momentum, etc. Depending upon whether they're elastic, inelastic. We have discussed those things also previously, if you remember. So this is a question from JAM 2012. Three masses, M, 2M, and 3M, are moving in the XY plane with speeds of 3u, 2u, and u respectively, as shown in the figure. The three masses collide at the same time at point P and stick together. The velocity of the resulting mass would be what? Now, इस क्वेश्चन को पढ़ते ही सबसे पहले हमें क्या चीज मालूम चलता है? If you read this question, the first thing you notice based on the question is
there is no external force.
There is no external force. Correct. Fine. This is an isolated system. But यहाँ पे एक term दिया हुआ है, they stick together. Do you notice
Inelastic
this?
collision.
Inelastic collision.
It is a perfectly
Inelastic collision. So
yes, perfectly inelastic collision. I hope that all of you guys remember our discussions from one of my earlier classes. Let me see if I can go back to those notes. Lecture number. Not this one. Not projectile motion. Yes, this lecture number 9. So here we talked about elastic, inelastic collisions and all these things. So this is the essential sort of a classification that if you have elastic collisions, then linear momentum as well as kinetic energy are conserved. And the coefficient of restitution is exactly equal to 1. If you have inelastic collision, then only linear momentum is conserved and kinetic energy is not conserved. So coefficient of restitution is greater than 0 but less than 1. Conservation of total energy doesn't happen because there is some sort of a dissipation of energy. In perfectly inelastic collision, the objects merge together after the collision, as a result of which coefficient of restitution becomes 0. Conservation of energy, kinetic energy doesn't happen, but conservation of linear momentum does happen. Okay. So we will be assuming these criteria here also. So it's a very simple straightforward question guys. जैम का सवाल है, typical जैम का सवाल है, typical जैम का सवाल. हर साल there is always some question on something related to collisions. So please give it a try. See if you can solve it. Three objects coming together from different directions. You can see the diagram here in the XY plane with different velocities at different angles with different masses come together, stick together. What is the velocity of the resultant mass? That's right. Yeah, Akshay, correct answer. Kashan, correct answer. Bamdev, it is not correct. Rakesh, not correct. Vidyut, not correct. Vivek, correct answer. Okay, मैं शुरू कर देता हूँ. See, this is a very, as I said, very typical question in JAM. इस तरह के questions आते हैं. You will have some sort of a collision that is happening and you might have to find something in that particular collision. Majority of the time, you need to apply conservation of linear momentum. Sometimes you may have other things like conservation of energy as well. Now, why is this question sort of interesting? It is interesting because the collision is happening on a plane. Usually आपने शायद अगर 11th 12th में collision के problems करे होंगे, which you must have done. You must have done questions where the collisions is happening along a particular axis, x-axis respectively. Here the collision is happening in the xy plane. So we will have to take care of conservation of momentum along x-axis as well as y-axis. So there are multiple things happening here. Okay. First of all, this is a perfectly inelastic collision, which means what? It means that the summation of the momenta is a constant, right? Not the summation of kinetic energy, but the summation of the momenta is a constant. But यहाँ पे भी दो चीजें आती है. You have to understand this. The summation of the momenta along the x-axis is a constant, and the summation of the momenta along the y-axis is also a constant. Yes or no? बताइए. The momenta is conserved along the x-axis as well as along the y-axis separately. Is that clear, everyone?
Yes, sir.
Yes?
Yes,
देखिए
sir.
मैं yes, okay. Bamdev and Swarnava, now your answer option is correct. Fine. See, why I'm mentioning this? Because it is a collision that is happening in 2D, right? Usually you might have seen problems of collisions related to 1D. So now you should also be capable of solving collision problems in 2D or 3D. If you go to 2D or 3D, then if you find that the entire system is isolated, then the summation of the linear momenta along the individual axes are going to be constant. So that will give us two different equations. So I can say that along x-axis, what is the component of momenta? So if we look at this mass, momenta is along the x-axis m times 3u, right? What is the momenta of this mass? बताइए. 2m along the x-axis. What is the momenta of the second mass along the x-axis?
Minus 2m.
2m is the mass, 2u is
Minus.
this minus. Is this correct?
Sir, half होगा.
Sir,
Half
cos
क्यों?
60 आएगा.
So, so cos 60.
Cos 60 आएगा. ठीक है, very good. This is what I was interested in. See this, I am interested in the momenta along the x-axis. So I am interested in the component of the momenta along the x-axis. I am not interested in the absolute value of the momenta. Okay? अगर आपने notice किया होगा starting से लेके अभी तक मैं जो भी बोल रहा हूँ, I am only talking about the momenta along a specific direction, right? Along which the force is zero. In this case, the force is zero everywhere because it's an isolated system. Therefore, we are looking at the momenta components along the x-axis first. Now, what about the third one? What is this? What is the momenta along the x-axis of the third mass?
minus 3m into u into cos 60.
Minus 3m into u into cos 60.
60.
Yes, correct. Now, what will this do? This will all get added up to the final mass. What is the final mass? All the masses stick together. So m plus 2m plus 3m. I don't know what the final mass velocity component is. मैं इसको बोल देता हूँ vx. Fine. So this simply equation simplifies to 3mu minus 4mu. Cos 60 आएगा तुम्हारा हाफ, तो ये हो जाएगा 2mu minus 3mu. Cos 60 यहाँ पे आएगा half, so you will end up getting 3 by 2 mu is equal to 356 mvx. So therefore this becomes 3 minus 2 is 1 mu. 1 mu minus 3 by 2 is 2 minus 3.
Minus half.
Minus half mu is equal to 6 mvx. यहाँ पे m and m gets cancelled, and you end up getting Vx is equal to minus 1 upon 12u. Who can tell me what is the meaning of this minus in the Vx sign?
Along negative 6 direction.
Very
The
good.
total mass.
Oh, what do you mean total mass?
The total mass will move along this direction.
Negative
Finally,
x-axis.
negative. Yes,
Yes,
sir.
negative x-axis. Correct. Fine. And similarly, if we look at along y-axis, I can do the same thing. What is the momentum of m 3 times u along the y-axis?
0.
This is 0. All right, so along the y-axis, this is simply equal to cos 90, which is 0. And what about this one? 2m 2u along the y-axis?
Into root 3 by 2 for sin 60.
तो ये हो जाएगा sin 60 minus, and this one
3mu and sin 60.
3mu, ये प्लस होगा ना, प्लस हो जाएगा 3mu sin 60. So this is equal to again m plus 2m plus 3m, velocity along the y-axis vy. So therefore this becomes, this is 0 minus 4mu sin 60 is root 3 by 2 plus 3mu root 3 by 2 is equal to 6m vy. So therefore this becomes root 3 by 2 minus mu is equal to 6m vy. So here m and m gets cancelled, and you are left with vy is equal to minus root 3 upon 12u. So therefore finally the velocity of the resultant mass is vx I cap plus vy j cap. So this is equal to vx is, so u upon 12 minus x cap minus root 3 y cap. That's it. This is your answer, option number D. All right. Not very difficult, but you will have to apply conservation of momentum components along the x-axis and along the y-axis separately. You have to apply conservation of linear momentum components along the x-axis, along the y-axis separately, because this is a collision that is happening in 2D plane. All right. Okay. Again, collision is a very common topic. Monzurul, your answer is correct. Therefore, it's good that if we practice few more questions of slightly different types. So let me see. Slightly different type of questions. All right. There are questions involving multiple collisions. So you can have a sequence of collisions that take place one after another, and all you have to do is somehow connect the sequence of collisions together. Okay. So this is your next question. Again, it involves conservation principles. You just have to connect the dots because there are a sequence of collisions that are taking place one after another. So three particles A, B, and C of masses small m each and one particle capital D of mass capital M are kept at rest on the x-axis. Particle A is given initial velocity v along the x-axis. Consequently, there are three collisions, all of which are completely inelastic. If the net loss of energy because of the collisions is 7/8 times the initial energy, find the value of capital M. तो एक ही रूट में चार ऑब्जेक्ट्स रख दिया गया है A, B, C, D. All of them are at rest. A starts with initial velocity small v. It collides with B. It is a perfectly inelastic collision, so they stick together. The whole mass collides with C. Perfectly inelastic collision, so they stick together. And then the whole mass collides with D. Perfectly inelastic collision, so they stick together. In this entire process, the loss of energy is 7.8 times the initial energy. So now find out the value of the mass of the last body. Try. Take 3 minutes, try to solve this. कॉन्सेप्ट वही है, कंजर्वेशन ऑफ लीनियर मोमेंटम यूज होगा यहाँ पे, एंड बिकॉज इट्स अ परफेक्टली इनइलास्टिक कोलिजन, कंजर्वेशन ऑफ एनर्जी नहीं होगा, इनफैक्ट देयर इज अ लॉस ऑफ एनर्जी दैट इज टेकिंग प्लेस. तो वही गिवन जो भी चीज़ है उसी को एज अ इक्वेशन यूज करके यू ट्राई टू सॉल्व इट.
Sir, one question may I ask?
Yeah.
Sir, in the first question you have done, there was two region, first region and second region. So for the both of the region, their potential energy was different. So when a particle moved from region one to region two, sir, how is the conservation of total energy is valid? Because region is changing. So
The kinetic energy changes according to the potential energy.
I can't imagine it. So that's
So
why I
think
was-
of it like this. T1 plus U1 is equal to T2 plus U2. Yes?
Yes, for general it is true.
Yes.
When we're dealing with a simple medium, because I have done all the question in the previous year for the region one only, because there was no second medium like this.
So you're seeing this kind of question for the first time?
Yes, sir.
Okay, so let's understand this. This equation is valid throughout the motion. Yes?
Why is it valid throughout the motion? I can't understand it.
Because there is no dissipation involved here. There is no drag. There is no friction. It is an ideal system. And in ideal systems, conservation of mechanical energy holds true. We discussed this earlier. Don't you
But
think?
sir, there is a force, so the force might change something like
Okay.
because
All right.
because
So let me give you an example of a different example. जब मैं किसी बिल्डिंग से एक बॉल को गिराता हूं, do you think that the total energy changes?
no.
The kinetic energy plus potential energy here and the kinetic energy plus potential energy here, they are equal, right?
Yes, sir.
But there is a force there, right?
Yes, gravitational force.
So what does the force do? It simply converts the kinetic to the potential energy. But the total amount of energy is a constant of motion. Yes or no?
Oh, so the force changes the something that balance out the total thing.
Yeah, force is simply the negative gradient of the potential. So the potential field, if the potential field is not constant, if it is changing, that automatically translates to a force. But that does not mean that the conservation of principle is not going to be valid. The conservation principle of mechanical energy is not valid only under the presence of non-conservative forces. That is the only criteria. Why? Because non-conservative forces essentially transform mechanical energy to non-mechanical energy, like sound, heat, other light energy and all these things. तो नॉन कंजर्वेटिव फोर्सेस क्या करते हैं? मैकेनिकल एनर्जी को नॉन मैकेनिकल एनर्जी में कन्वर्ट करते हैं. देयरफॉर वी डू नॉट अप्लाई conservation of mechanical energy in non-conservative forces. But if you can apply this expression, automatically it means that we are dealing with conservative forces. So therefore, I automatically apply the conservation of mechanical energy.
Okay, sir. I understand, sir.
Okay, okay. All right, guys. Next question. Not a very difficult one. Slightly different in the sense that it has multiple collisions that are happening. Oh, sorry. Let me reshare. Yeah, Rakesh, correct answer. Swarnava, Vivek, correct answer. Bamdev also correct. Very good. Wanzurul, it's not correct. Check your calculations again. सिंपल सवाल है, बहुत कोई डीप कॉन्सेप्ट नहीं है. You just have to compare the first collision with the last collision. That's all. Akshay, your answer is correct. All right. See, again, simple question, not very difficult. You have this kind of a system in which there are multiple collisions that are happening. First object strikes with the second object, collides, sticks together. The entire mass collides with the third object, sticks together. The entire mass collides with the last object, sticks together. And because they're sticking together, it is essentially a completely inelastic process. So there is a certain loss of energy that takes place, but we can still apply conservation of linear momentum. So if you apply conservation of linear momentum, let's say initially and finally, okay? So that means summation of all the momenta initially and finally. So what is the initial momenta? mv plus m0 plus m0 plus capital M0, because except for mass A, all the other masses were at rest. What is the final momenta? Because they've all stuck together, m plus m plus m plus capital M. This is the final object after having stuck together. And let's suppose it has a velocity of v, let's suppose, along the x-axis. Okay. So if I do that, what do we get? So small m, no, I should do something else. Let's suppose there's a velocity v dash. So mv is equal to 3 small m plus capital M v dash, or therefore v dash is equal to small m upon 3 small m plus capital M v. Okay, now let's go to the question. It says that the net loss of energy, so it's given that the net loss of energy is equal to 7.8 times the initial energy. 7.8 times the initial energy. Now here there is no potential, so we are only talking about kinetic energy initially. So what is the loss of energy? The kinetic energy initially minus the kinetic energy finally is equal to 7.8 times the kinetic energy initially. That's it. This is given in the question. If you are able to figure out this, then everything else is done. You don't need to do anything else. So the loss of energy, there is a, because यहाँ पे कोई potential तो है ही नहीं. This is an isolated system experiencing collisions. So the only energy here is kinetic energy. So the total initial kinetic energy minus the total final kinetic energy represents a loss in energy is equal to 7.8 times the initial kinetic energy. That's it. You just solve it, you will get the answer. Conceptually इससे ज़्यादा और कुछ है नहीं यहाँ पे. So this is half m v square minus this is half. What is the final mass? 3m plus capital M. Final velocity v dash square is equal to 7.8 times half m v square. That's it. This is the equation. इसको solve करेंगे तो हमें आंसर मिल जाएगा. So half तो गायब हो ही जाएगा वैसे भी, and this becomes small m v square minus 3 small m plus capital M. What is v dash? We can apply from here. So v dash is equal to small m upon 3 small m plus capital M square. V square is equal to 7 upon 8 m v square. Okay, so we are left with, so ये तो हो गया cancel 3, so this becomes small m v square minus ये m square v square upon 3 small m plus capital M is equal to 7 upon 8 small m v square. So v square v square v square cancel, small m cancel. We are left with small m upon 3 small m upon capital M is equal to 1 minus 7 upon 8, which is equal to 1 upon 8. So finally 3 small m plus capital M is equal to 8 small m, or capital M is equal to 8 small m minus 3 small m is equal to 5 small m. That's it. Done. Answer is option number B. These kinds of questions are typical JAM questions, not very complicated, not very hard, not very easy, but they will challenge your basic understanding of the concepts of linear momentum हो या कुछ भी हो. ठीक है? All right. I hope that those students who are not able to solve the questions are also learning from the process and becoming more and more familiar with how to solve these questions. 2-4 और questions try करते हैं. There is a question from JEST, पर इसको मैं homework में दे दूंगा. All right, a relatively easy question, but slightly different from the others. Yes, please try this. A bullet of mass small m leaves a gun of mass capital M kept on a smooth horizontal surface. If the speed of the bullet relative to the gun is v, what is the recoil speed of the gun? Try. Classic question on conservation of linear momentum.
सर ये जो रिकॉइल स्पीड ऑफ द गन है ये रिलेटिव टू बुलेट है.
No, I think it is relative to the shooter. Question is not very clear, but I think it's relative to the shooter. Let me check. It is relative to the shooter. वैसे ही करो आप.
Sir, while talking about momentum, you were saying something about symmetry. What is it?
The universe. It's called Noether's theorem. Have you heard of Noether's theorem?
Yes, but I don't know what it is.
So Noether's theorem essentially says that in classical mechanics, all the conservation laws are associated with some fundamental symmetry of the universe. So for example, whether you look at conservation of energy, whether you look at conservation of linear momentum, whether you look at conservation of angular momentum, these all things are related to some fundamental symmetry of the universe. So in short, conservation of linear momentum has to do with translational symmetry. Pardon? Conservation of angular momentum has to do with rotational. So the universe physical laws are same in all directions. The conservation of energy has to do with temporal symmetry, time symmetry, that the physical laws do not change with time. So if you want, you can study a little bit about it. जैसी उपाध्याय में दिया हुआ है, अगर आपके पास है तो आप देख सकते हो. वैसे कॉलेज में ज़रूरत नहीं होता है, एमएससी में पढ़ोगे आप इस चीज़ को.
So are these symmetries related to group theory?
I'm not really sure. I'm not very much of an expert on that matter actually. Not really sure. Classical mechanics में जो symmetry है, this came much earlier actually in the 1700 itself. So this has to do with the invariance of the Lagrangian. So you can, if you are interested, I mean, you will not have this in BSc syllabus. So if you're interested, you can check out JC उपाध्याय. वहाँ पे दिया हुआ है, या फिर तायल चाओ और तायल चाओ आप पढ़ सकते हो नॉर्डर्स थ्योरम के बारे में. How the conservation laws arise from certain symmetries of the universe. हो गया? Answer to this question? Monzurul, your answer is not correct. Kashan, not correct. Shoel Hussain, not correct. Sampurnananda, your answer is also not correct. Atanu not correct. Rakesh Malik correct answer. Uttam correct answer. Bamdev and Akshay not correct. Vivek, I have classical mechanics in this semester and professor is following JC Upadhyay. It's fine, fine. JC Upadhyay is a very simple, easy book. And it also has a lot of problems. So it has a lot of, the good thing about JC Upadhyay is that at the end of each chapter, they include certain problem solving exercises. So that helps you in understanding how to apply the Lagrangian or the Hamiltonian dynamics in problem solving. Usually many other books do not have. For example, like if you look at Goldstein is a very famous classical mechanics textbook, but Goldstein doesn't really provide too many examples. It only focuses a lot on theory. So for a beginner, it can become a very difficult textbook actually. But from a beginner's perspective, JC Upadhyay is a good book to get introduced to the subject, but of course it's not very rigorous in its theory. So once you understand JC Upadhyay, you can move on to Goldstein. Karthik, your answer is not correct. What happened? I'm trying to make it clear that the recoil of the gun is measured with respect to an observer, like a rest observer, like a shooter. And then simple momentum conservation should give you the answer. Come on. It's a very easy question, guys. I think in the last 4 questions, this is the most easiest, right? A gun shoots a bullet. Velocity of the bullet is given to you. What is the recoil velocity of the gun? That's it. इससे ज़्यादा easy क्या हो सकता है? How much more easier a question Vidyut again not correct. Sometimes the easy questions are most difficult to solve because there's something lacking here. Can I tell you where everybody made the mistake? Maybe you can give it a check. Everybody made the mistake in this particular thing. The velocity of the bullet is relative to the gun, not relative to the shooter. This is where everybody made the mistake. So if you want, you can check your calculations again. The velocity of the bullet is not with respect to the shooter. It is with respect to the gun. So think how that will influence your calculations.
सर
Yeah.
सर वो जो आपने डिक्लेयर किया था कि संडे को टेस्ट होगा, उस टेस्ट का टाइमिंग क्या रहेगा सर?
So the thing is, this is an online test. So usually what we do is I don't keep a fixed timing, because then what happens is that if I keep a fixed timing, then some student is going to message me, sir, I have this thing to do at home. Can you change the timing? Yeah, somebody will say, sir, मैं आज free नहीं हूँ. Can you change the timing? So keeping a very hard and fast timing window is not like सबके लिए थोड़ा मुश्किल हो जाता है. So what I do is I will keep the test open for a day or 2 days max, Sunday and Monday. So what that means is that you will have access to the test on Sunday and Monday. Now, at what point you want to sit down and attempt the test is up to you. Like you can attempt in the morning, Sunday morning, or you can also attempt in Monday evening. मैं Monday 11 बजे तक खुला रहूँगा, Sunday 9 बजे से 9 AM से Monday 11 PM तक. So the test is going to be available to you in this window. But once you open the test, then you have to attempt the test. So you make sure that whatever time you are free in the Sunday morning, Sunday evening, Monday morning, Monday evening, जब आप free हो, you are ready. Then you sit down on your mobile or your laptop, you open the test, and once you open it, you'll have 1 hour to complete. And then you attempt it, okay? I think that is comfortable for everybody, right?
Yes, sir. Thank you, sir.
Okay. Bamdev, Vidyut, Shoel, and Kashan, now your answer is correct. All right. तो मैंने hint दिया तो आपको थोड़ा समझ में आ गया है ना? Okay. Anyone else? Questions on collisions तो बहुत सारे हैं. All right, let's start. Akshay, Monzurul, Sampurnananda, and Bamdev, now your answers are correct. All right, very good. So you got the hint, right? Essentially what happens is that many times in questions in mechanics, some vital information is hidden in the text. If you do not read the text clearly, you can lose some important information. So the important information here was the speed of the bullet relative to the gun. If you are too much in a hurry, you would probably go through the question like tick, 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 and then okay, MV, and suddenly आप करोगे answer देके आ जाओगे, you'll be confident. But later on when you check, oh, I made this slight mistake, the answer is wrong. That happens most often. So we have to be very careful that some crucial piece of information can be hidden in the text of the question. So let me just draw a diagram and make the whole thing clear to you. So you have essentially you have a gun. Let me try to draw a gun. You have a gun here, right? And the gun essentially shoots a bullet. Fine, all right, no problem. The gun shoots a bullet. And as we know from conservation of linear momentum, whenever this kind of a thing happens, because the gun and the bullet, we can consider it to be a sort of an isolated system in the horizontal direction. So both the gun and the bullet will experience a certain kind of a velocity in their own directions. So let's suppose that I say that the gun has a mass of capital M and the bullet has a mass of small m. And I say that the bullet experiences a velocity of v1 and the gun experiences a velocity of v2. ठीक है, ये मैं mention कर देता हूँ for us. Now what happens in questions like these is that relative to what? Now usually whenever we solve problems of mechanics, we are not really that concerned with the velocity relative to what. When we study STR, then we will be much more concerned with this particular question. क्योंकि mechanics में क्या होता है? then in mechanics, most of us, we make the implicitly correct assumption that all the velocities are being measured with respect to the lab or some sort of a lab observer, okay, or a ground observer. We can call it a lab observer or a ground observer. Fine, as frame of reference. In STR, the entire theory of STR is very much dependent on making comparisons between the transformation of different physical quantities with respect to different observers. Therefore, in STR, we are very much, in every single question of STR, you have to be very careful about writing the various quantities with respect to different observers. And that is also true for mechanics, but the thing is, in mechanics, we sort of ignore it because that is not very important, because majority of the time we deal with problem solving with respect to the ground frame of reference. But sometimes it becomes important, especially in this question, because in this question, they have given us a physical quantity, which is a velocity with respect to a gun, which is also in motion. They have given us a velocity of a bullet with respect to a gun, which is also in motion, right? So therefore, when you do questions like these, jahan pe there might be more than one observer. यहाँ पे the ground is also an observer, the gun is also an observer. एक तरीके से देखा जाए तो. So there you have to be a little bit careful. Okay, little bit careful to make sure that you don't make a mistake. So हम क्या करेंगे? We will say that I want to perform the calculations with respect to the lab observer. Now, if I make calculations with respect to the lab observer, I'll keep all the physical quantities with respect to the lab observer. So I've defined the velocity of the bullet with respect to the lab observer. I've defined the velocity of the gun with respect to the lab observer. Now, with respect to the lab observer, I can apply conservation of momentum. So now if I apply conservation of linear momentum, what do I get? Based on my this thing, capital M V2 is equal to small m V1. That's it. No issues. But V2 is the velocity of the gun with respect to the lab observer, which is what the question is asking, recoil speed of the gun. And V1 is the velocity of the bullet with respect to the lab observer. सवाल में वो दिया नहीं है. सवाल में क्या दिया है? Velocity of the bullet with respect to the gun दिया हुआ है. तो वो हम क्या करेंगे? So उसके लिए I have to do another calculation. So velocity of bullet with respect to gun. ध्यान से सोचिएगा. Velocity of bullet with respect to lab observer is V1. But velocity of bullet with respect to the gun, which is also moving at a velocity V2 in the backward direction, is how much?
V1 plus B2. V1 plus B2.
Okay. So let me compare this with something very obvious.
V1 minus V2.
V1 minus V2. अच्छा, okay. आप रास्ते में खड़े हैं, ठीक है? तो आपके सामने से एक गाड़ी जाती है 100 किलोमीटर पर आवर, राइट? एक और दूसरी गाड़ी जाती है 50 किलोमीटर पर आवर. What is the velocity of this car with respect to this car?
150 kilometers per hour.
Okay. So velocity addition is something that we are all familiar with. All right. So that is what's happening here. तो यहाँ पे जो technically correct velocity addition expression है वो ये है that velocity of the bullet with respect to the gun is equal to the velocity of the bullet with respect to the lab plus the velocity of the gun with respect to the lab. So basically, sorry, plus नहीं, minus the velocity of the gun with respect to the lab, which is minus V2. इसको ध्यान से देखिए. Okay, usually the velocity addition क्या कहती है? Velocity addition कहती है that ux dash is equal to ux minus v along the x-axis. This is a velocity addition. जब हम STR में जाते हैं तो यहाँ पे of course एक modification आ जाता है, but under Galilean transformations, this is the velocity addition expression. All right. So the velocity of the bullet with respect to the gun is equal to the velocity of the bullet with respect to the ground observer minus the velocity of the gun with respect to the ground observer, जो minus v2 है. That's it. This is simply equal to v1 plus v2. Now I can connect the dots. Now I can connect the dots from here and here. तो यहाँ पे क्या हो जाएगा? This is going to become mv2 is equal to small m, v1 is equal to v minus v2. So v minus v2 or mv2 is equal to small mv minus small mv2. और हमें क्या चाहिए? हमें v2 चाहिए. So capital M minus small m plus small m v2 is equal to m small v, or v2 is equal to mv upon capital M plus small m. That's it. Option number B, small m upon capital M plus small m v. That's it. So you see the calculation itself is very easy. Now you may say, why am I spending so much time, right? You saw initially, apart from 2-3 students, everyone gave me wrong answer. Why did you give me wrong answer? Because you somehow missed a very crucial information in the text. The moment you incorporate that information, everything else falls in line. Okay, so that is what I want you to do, is to avoid certain silly mistakes that is very easy to make. Kitna time hai hamare paas? Half an hour more.
सर
Yeah.
सर वो जो सीक्वेंशियल फायरिंग का थोड़ा क्वेश्चन समझा सकते हैं, मतलब 5 बुलेट फायर किया, फिर थर्ड बुलेट और फिफ्थ बुलेट में स्पीड का रेशियो क्या है, वो क्वेश्चन को कैसे आप पूछ लेंगे, वो थोड़ा तो यही सेम लैंग्वेज सेम है कि बुलेट का स्पीड जो है वो विथ रेस्पेक्ट टू गन दिया हुआ है, और एक गन सीक्वेंशियली 5-6 बुलेट फायर किया, फिर फोर्थ बुलेट और सिक्स्थ बुलेट का रेशियो, स्पीड रेशियो क्या है, इस टाइप का.
So do you have a question like that with you?
ये सर एसी वर्मा सर, 1 मिनट आप थोड़ा होल्ड करिए, मैं दिखाता.
कोई बात नहीं, आप एक काम करो, why don't you share it in the group and I will solve it and send it to you, because there are certain parameters involved. Number one is the gun at rest all the time, or number two, of course, the mass of the gun is changing, so that is going to impact what is happening. So the masses of the gun is slightly going to decrease after every shooting. तो उन सब चीजों को लेकर के we can also solve it. Like for example, you did this question, right? It's like a similar question only. Repeated collisions are happening here. So the question you are asking is repeated sort of the reverse is happening. The reverse is happening. यहाँ पे एक collide करता है, stick करता है, दूसरे के साथ collide करता है. आप अगर उसको reverse में देखेंगे, that is what your question is, right? The bullet is more massive,
sir.
slightly it loses mass, and you see the velocities. So it should not be very difficult. आप एक काम करो, आप group में share कर दो. I'll look into the question. I'll try to solve it and send it back to you in the group. Okay.
Okay, sir.
Yep. All right. I have half an hour. Should I move ahead to a different topic, or? Should I give the collision related problems? Yeah, should I do it?
Sir, I am facing a difficulty to understand the relative frame.
Yeah.
The relative velocity concept is revised.
The relative velocity concept you are facing difficulty to understand mathematically, or like what? Like conceptually? You are unable to.
Conceptually, plus mathematically, I can't relate.
Okay. So अभी मैंने आपको जो एक एग्जांपल दिया था, 2 गाड़ियां जा रही है, were you able to solve that problem?
Yes, yes.
Okay, so that is conceptually you understand what's happening, right? If 2 objects are moving in opposite directions, the velocity of one object with respect to the other is always a sum. Yes? Okay, let me give you 2 questions. There are 2 cars. One is moving at 100 kilometers per hour in this direction, and another is moving at 50 kilometers per hour or 25 kilometers per hour in this direction. What is the velocity of this car with respect to the second car?
75.
75. So conceptually, you understand what's happening. Mathematically, what we end up getting is known as the Galilean transformations. So if you have two frames of reference, S and S dash, and S dash is moving with a relative velocity of v along the x-axis, and we are looking at the velocity of another object, and I'm saying the velocity of the other object is ux with respect to the S frame and ux dash with respect to the S dash frame, then in that kind of a situation, ux dash is equal to ux minus v. That's it. This is the Galilean transformations, or also known as a velocity addition that arises from the Galilean transformations. Conceptually, it's the same thing. अगर आप सेम डायरेक्शन में जा रहे हो तो 100 minus 25 हो गया. Yes or no? Velocity of the opposite direction में जा रहे हो तो यहाँ पे एक और माइनस आ गया, तो प्लस हो गया एक तरीके से. That's it.
The formula velocity of with respect to time.
I'm not able to hear you, Atanu. I'm not able to hear you properly.
The formula is velocity of bullet with respect to time.
No, your audio is not clear. It's very muffled. Can you check the connection? Can you say something, Atanu? Say something.
Hello?
Yes.
Can you hear me now?
Audio is quite muffled. You can repeat again. Repeat, it's okay.
Yes. Hello.
Yeah, now it's clear. All right.
So I'm saying that the formula velocity of bullet with respect to gun, it is a velocity of bullet with respect to lab observer minus a velocity of gun with respect to lab observer.
Yes.
When the motion is
Again, audio is gone.
hello.
Yeah, now it's back.
So when the motion is in horizontal direction, right?
Your audio is again gone.
Hello.
One more time.
Hello.
Yeah, it's working now.
Yes, sir. I'm saying that the velocity of bullet with respect to gun equals to the velocity of bullet with respect to lab observer, or minus a velocity of gun with respect to lab observer.
Yes.
Yes. This is only valid when the motion is horizontal or in a straight line, right?
Yes.
Yes. So if we have any angular direction like
Cos theta, sin theta.
okay.
Yeah, just like we did in the previous question.
Okay.
You take the component. These are vectors, right? You take the component.
Yes, I'm saying that this is the vector addition, right? The formula is in vector from.
Yeah, but usually we, because vector में थोड़ा complicate हो जाता है, तो usually we always focus our attention along the x-axis or y-axis. But overall, it's a vector addition. So if you are taking components, you just take a cos theta along that direction.
Okay.
Okay.
Yes.
So you can have questions in inclined direction. So for example, in STR, in JAM, there are certain questions that, let's suppose that there is an Earth and there is a rocket which is moving along this direction with a velocity v1, and another rocket which is moving in this direction along the velocity v2. What is the velocity of v2 with respect to v1? That is a question from JAM. It came a few years back. So what you do is, no need to worry too much. You take the component along the x-axis and y-axis, and you do the final velocity addition. So what is the relative velocity vx along the x-axis? What is the relative velocity vy along the y-axis? The final answer is vx square plus vy square root over. That's it. You take the components. Very easy, no problem. Okay? This is the method.
Okay, sir. Yes.
You take the relative velocity along x and y axis separately, and if you want to find the absolute value of relative speed, you just take root over vx square plus vy square. That's it. All right, let me give you a question, and let me see if you can.
सर
हाँ जी.
सर जो हम लोग पहला TIFR वाला जो क्वेश्चन किए थे
Yeah.
सर उसमें हम लोग फोर्स इज इक्वल टू माइनस ग्रेड ऑफ v लिए
Yeah.
तो सर हम लोग का x डायरेक्शन में नेट फोर्स 0 क्यों हो रहा?
नॉन जीरो है ना.
हाँ सर वही नॉन जीरो क्यों हो रहा है?
Because there is a potential gradient. Gradient का मतलब वो क्या होता है? Change. Is it changing or not changing?
मतलब सर चेंज कैसे कर रहा है?
अच्छा, ये यहाँ पे U1 था, यहाँ U2 हो गया, तो चेंज हुआ कि नहीं?
तो सर ऐसा नहीं, मतलब यहाँ पे तो क्वेश्चन में कुछ बोला नहीं है U1 और U2 अलग है, क्योंकि लिखा दे आर कांस्टेंट पोटेंशियल U1 और U2।
But the velocity is changing, na? The angle it is making with the horizontal direction is changing. That means kinetic energy is changing. So if kinetic energy is changing, so the potential energy must change to keep the energy conserved.
Yeah. So in general, this is correct.
Also, yeah, the net force is zero, right? And not equal to zero.
No, net force is non-zero along x-axis, but zero along y-axis. वही तो मैं बता रहा
Yes,
हूँ.
yes. I mean, in the x direction, this is the net force.
Yeah, as a result of the potential gradient. As a result. See, if I tell you that there is a motorcycle, okay, there's a motorcycle which is traveling, and initially the motorcycle had velocity v1. After some time, there was a velocity v2. Would you say that there was an acceleration somewhere at that point? There must have been, right? What is acceleration? It's time derivative of velocity. So because the velocity has changed, there was an acceleration somewhere. So here the potential has changed. So there is a force somewhere as it goes from region 1 to region 2. So based on this, potential changes as you move along a region, along a spatial direction. This is a spatial direction. This is a temporal direction, spatial direction. So that means there is a force. So whenever you get a question where you have some sort of a question related to this kind of a figure, where in one region, one potential, another region, another potential, you automatically have an additional concept in your mind that there must be a force in that particular direction. Now, whether that concept is important or not depends upon that question. But now you have this additional thing that agar potential alag-alag hai, so in that region there is a force, and you can use whatever concept necessary in that particular problem to solve it. Okay. Now, are they equal or not equal? Doesn't really matter. If they are equal, then automatically this expression is going to transform in a very specific manner. So it has to be non-equal. That is why they have given the question, right? Sometimes some of the things that they give in the question are slightly implicit. So try not to read too much. See, the thing is, as competitive exam, it's very important that you have to read into the question, but not too much into the question. So you read into it, try to find out, अच्छा एक बहुत specific चीज बोला है, इसको मुझे include करना है, but not too much into it. Don't do brainstorming of the question, okay? If they are saying there are two constant potentials U1 and U2, best assume that they are not equal. All right, okay. Even if they are equal, my general answer is anyways correct. Okay, एक सवाल देता हूँ, थोड़ा सा मुश्किल हो सकता है, but it's an interesting question, so I'm giving it to you. Because other time मेरे पास है नहीं, SHM मैं अगले क्लास में करूँगा, अभी मैं एक और यही सवाल दे देता हूँ. So there's a question related to collision again, but it's a collision that involves a pendulum, which makes it an interesting question. Okay. So a horizontal flying bullet of mass m gets stuck in a body of mass capital M suspended by two identical threads of length L. As a result, the system gets displaced by an angle theta, assuming small m is very, very small compared to capital M, find the fraction of the bullet's initial kinetic energy that gets dissipated, that is lost. Okay, so this is the diagram. The diagram is important. So imagine that there is a like a pendulum kind of a system like this. So here is a thread, here is a thread, so there is a sort of a rigid object like this. Okay, so there is a bullet of mass m that comes and strikes this. Okay, so bullet of small mass m gets stuck in a body of capital mass M suspended by two identical threads of length L. As a result, the system gets displaced. तो ये pendulum की तरह behave करता है. तो the system gets displaced by an angle theta. Okay, as a result of this collision. So what is the fraction of the bullet's initial kinetic energy that is lost due to sound, heat, or whatever? ठीक है? And get stuck. This is important. Get stuck का मतलब क्या है? This is a perfectly inelastic collision. Try it. Options मैं आपको दे देता हूं. Try this. So you essentially have a pendulum of mass capital M suspended by two strings, and a bullet comes and hits the pendulum, and because it is a perfectly inelastic collision, it gets stuck to the pendulum. So assuming small m is very, very small compared to capital M, what is a fraction of bullet's initial kinetic energy that is lost? So you can take velocity v naught or whatever. Try it. Very easy question. Rakesh, your answer is correct. Vivek, correct answer. Very good. Atanu, correct answer. Vivek Babu, correct answer. This is a relatively easy question because I'm asking you the loss in kinetic energy. I can actually make it more difficult if you want. Like I can ask you, what is the angle up to which the pendulum is going to climb? Can you solve that? मैं उसको add कर दूं क्या? Would you like to try solving that also?
Yes, sir.
तो मैं इसको दो parts में divide कर देता हूँ. First part is the loss of the kinetic energy. That's the first part. Okay. Let's suppose this is point number 1. And the second part is find the angle theta if initial velocity of bullet is v naught. Try. I made it a little complicated. First, you try to solve the first part, the loss of kinetic energy. That is easy. Second part, uske baad karo that what is the angle up to which the pendulum is going to climb after it is hit by a bullet with velocity v naught. Try it, obtain it according to your own way. स्टार्ट कर दें. मैं स्टार्ट कर देता हूँ. विवेक हैज ऑब्टेन द एंगल. ऑप्शन नहीं दिया है तो अभी चेक करते तो पता लग जाएगा. ओके, दिस इज अ वेरी सिंपल प्रॉब्लम ऑफ collision. The only difference is that here you have the collision between a point mass and a pendulum or a compound system. Okay, but we need not worry about anything else. Let's say that the bullet speed before collision is equal to v naught. Okay, and the system speed after collision, system means bullet plus pendulum, is v. Then what does conservation of linear momentum tells us? Conservation of linear momentum says mv naught is equal to capital M plus small m v. ओके, तो इसका मतलब क्या हो गया? v is equal to small m upon capital M plus small m v naught. Now find the fraction of bullet's kinetic energy that is lost. Fraction of bullet's kinetic energy that is lost is equal to the loss in kinetic energy upon the initial kinetic energy, right? Right. Fraction जब भी हम बोलते हैं, whenever we say fraction of something, you take the loss or the change upon the initial quantity. So what is the change? So kinetic energy initial minus kinetic energy final upon kinetic energy initial. So what is kinetic energy initial? Half m v naught square. What is kinetic energy final? Half capital M plus small m v square. This is equal to half m v naught square. So what is this? This is equal to half small m v naught square minus half capital M plus small m. What is v? v को यहाँ से substitute कर देते हैं. This is going to become small m by capital M plus small m square v naught square upon half m v naught square. If I simplify it, this is going to become half small m v naught square minus half capital M plus small m हो गया half small m क्या होगा यहाँ पे small m upon capital M plus small m v naught square upon half small m v naught square. So this is going to be equal to, ये तो cancel हो जाएगा ना, half ये cancel हो जाएगा. So we are left with 1 minus small m upon capital M plus small m. This is equal to capital M plus small m minus small m. So capital M plus small m. This is the answer. That's it. Option number A is the correct answer. Option number A is the correct answer. So it was not very difficult. It looks difficult initially, but once you make the diagram and you apply the concept, here the concept is of course conservation of linear momentum, and the rest is just the definition of what a fraction of kinetic energy lost is. When you substitute everything, you get the answer. Perfect.
सर
Yes.
सर इसमें सर ये जो ये मतलब पेंडुलम जैसा जो सिस्टम है,
Yeah.
ये रोटेट कर रहा है, तब फिर भी लीनियर मोमेंटम कंजर्व रहेगा.
तो हमने collision के immediately बाद velocity measure किया है ना. What is the system speed right after collision? Right after. तो जैसे जैसे वो ऊपर जाएगा वेलोसिटी कम होगा.
बट सर इसमें तो एंगल थीटा दे रखा है ना, मतलब राइट आफ्टर केस लूप.
अरे नहीं, राइट मतलब कलाइड करने के बाद वो स्विंग करेगा ना, स्विंग करके थीटा तक जाएगा ना.
यस सर, तो मतलब मैं यही पूछ रहा हूँ कि अगर रोटेट कर रहा है फिर भी लीनियर मोमेंटम उसका कंजर्व है.
नहीं, रोटेट तो वो एक ओवरऑल मोशन हो गया ना. इमीडिएट जब कलाइड करेगा तो कंजर्वेशन ऑफ लीनियर मोमेंटम तो होगा ना. इनिशियली वो रेस्ट पे था. इनिशियली जो सिस्टम है ना, देखो इनिशियली इसका वेलोसिटी था v नॉट और इसका वेलोसिटी कितना था इनिशियली कलिजन से जस्ट बिफोर. 0. Yes. Yes.
यस
Yes. collision का immediately बाद क्या होगा? बुलेट स्टक हो गया और ये जो पूरा m प्लस m सिस्टम है इसका एक वेलोसिटी होगा स्मॉल v. बस मैं उसकी बात कर रहा हूं. नाउ इस
So the
स्मॉल v
question
की
is right after the collision, right?
या
Right after collision, what fraction of kinetic energy get lost?
yeah, because loss will happen at the point of collision only. After that, so it doesn't matter.
Yes,
तो
because
सर अगर
time passes, the system will be inclined at an angle theta with the vertical. So
No, it will be oscillating with respect to theta.
this is oscillating.
Yeah.
ये सर अगर हमें क्वेश्चन ऐसे दिया जाता है कि ये राइट आफ्टर नहीं लिखोगा बल्कि मतलब आफ्टर सम टाइम सम पर्टिकुलर टाइम तो फिर हम मतलब इसमें कैसे लगाएंगे?
No, right after तो मैंने भी नहीं लिखा है. मैंने लिखा है as a result the system gets displaced by an angle theta. ये लिखा था. मतलब collision की वजह से वो थीटा तक डिस्प्लेस हो गया ना.
सर आई थिंक यहाँ पर मास तो वेरी वेरी लेस है, स्मॉल मास जो है,
हाँ वो
इसलिए हो सकता है कि डिस्प्लेसमेंट बहुत
समझा
छोटा होगा एकदम,
तो
इसलिए
इसमें जो वेलोसिटी आपने ली है वो राइट आफ्टर वाली ली है पर उस वेलोसिटी की वजह से ये थीटा तक डिस्प्ले
yes correct.
यस सर ठीक है
ठीक है.
yes,
ओके पूरा जो सिस्टम है it will gain a velocity जिसकी वजह से it will get displaced to theta. That is what I meant. As a result the system gets displaced by an angle theta. और आप ऐसे भी बोल सकते हो as a result the system swings up to angle theta लिख सकते हैं. swings up लिख देता हूं मैं अगर ये थोड़ा कंफ्यूज कर रहा है. the system swings up to an angle theta. ठीक है. because the system was initially at rest but वो collision की वजह से suddenly it becomes like a moving pendulum. alright. ठीक है आगे बढ़े. तो I am just comparing the movement before the collision and movement after the collision. That's it. Overall तो फिर बाकी चीजें आ जाएंगी ना जैसे मोशन होगा आगे और other things will come into play. Yeah. Find the angle theta if the initial velocity of bullet is v naught. अब बताइए ये कैसे फाइंड आउट कर सकते हैं एंगल थीटा. How
The
can I find out
potential energy is equal to kinetic energy because at the in the highest angle the potential energy will be equal to the kinetic energy at the start from the equilibrium position.
Yes, very good. So we can apply conservation of energy. So right after collision, what is the kinetic energy plus potential energy initially for the overall system is equal to the kinetic energy plus potential energy later for the overall system. So what is the kinetic energy of the overall system? Half capital M plus small m v square, right? What is the potential energy of the overall system? If I consider this to be the reference for the potential, इसको मैं ground मानूं, ground reference for potential V, then this will automatically be 0. And at the highest point में तो of course वो rest पे ही आ जाता है. So half capital M plus small m 0 square. What is the potential energy at the highest point?
M plus mgl 1 minus cos theta.
Yes.
mgl 1 minus cos
Capital M plus small m g h. But what is h? So if you look at h, अगर हम h को measure करें, h is simply equal to L 1 minus cos theta. L 1 minus cos theta. ठीक है. So therefore this we can write as mg small l 1 minus cos theta. So therefore this becomes half capital M plus small m v square is equal to, तो v square की जगह हम क्या लिख सकते हैं? v square is equal to small m by capital M plus m, ये लिख सकते हैं small m by capital M plus m square v naught square is equal to capital M plus small m gl 1 minus cos theta. So here this essentially becomes half small m upon capital M plus small m upon capital M, V naught square is equal to तो क्वेश्चन क्या था? क्वेश्चन वाज फाइंड द एंगल थीटा इफ इनिशियल वेलोसिटी ऑफ बुलेट इज v नॉट. हम इसमें कर क्या सकते हैं सिंप्लीफाई करने के लिए?
सर और कुछ तो नहीं होगा, बस मतलब हम cos थीटा को एक साइड भेज देंगे, फिर कॉम्प्लिकेटेड सा
सर 1 minus cos theta equal to 2 sin square theta by 2.
So, or we can approximate
taking
1
small
minus
angle
cos
approximation.
theta is equal to 1 minus theta square by 2. So that will be theta square by 2 in general.
या यू आर करेक्ट. एक और अप्रोक्सीमेशन दिया हुआ है ना, स्मॉल m इज वेरी वेरी लेस. ये भी अप्रोक्सीमेट कर सकते हैं. स्मॉल m इज वेरी वेरी लेस देन
But sir, where will we use that approximation? Because I think it's not needed here.
Sir, that capital M plus small m will be cancelled out, I think.
no, it will get
Just
multiplied now.
it's in both sides, na sir? So it will be 1.
No, it is in the numerator in the right hand side and denominator in the left hand side.
No,
So
not that. So in the previous line, you can see like capital M plus small m into the square, and in the right hand side, there is also a capital M plus small m there.
so essentially this gets cancelled and we are left with basically this. We are left with this, but ये हो गया आपका m square, this one. This is the expression we are left with.
That is
So,
basically same. Nothing is different.
yeah, it's the same thing. So I was thinking, how can I simplify it? One simplification is 1 minus theta square upon 2, but that is a small angle approximation. Should I take a small angle approximation?
Sir, if m is very,
Yes,
very
sir,
less
as the
than
mass
the
is
capital
dependent
M,
on
so
small
the
mass.
displacement will be generally small. In that sense, we can think it.
Yeah, you're
Can't
correct.
we?
Yeah. In that
But sir,
situation,
theta is already depends upon the velocity. So
No, if the small mass have the for example, have the larger velocity, but the capital M is very, very large, so this displacement will be very, very large after getting stuck. In that sense.
no, but it will depend upon both the mass and the velocity. So therefore, I can't really take it. Because even if the mass is very, very less, if the velocity is very, very high, then the displacement we can't really say without having values.
yes, sir, exactly. So from this step, we can direct calculate the theta from 1 minus cos inverse of.
I can simplify it by saying that so cos twice theta is equal to 1 minus 2 sine square theta, right? So I can say 1 cos theta is equal to 1 minus 2 sine square theta by 2, or 1 minus cos theta is equal to 1 minus 1 plus 2 sine square theta by 2. That simplification I can make. So therefore this is equal to half small m by capital M plus small m v naught square is equal to gl times 1 minus cos theta is equal to twice sine square theta upon 2. So finally यही आ गया एक तरीके से without using any other approximation. Sine square theta upon 2 is equal to 1 upon 4 small m by capital M plus small m, and 1 upon 4 1 upon GL. That's it. Or
There is a square you missed, sir. Square term.
V
Small
naught
m by
square. There's
no
a
no
square term. Yeah,
m
square
by
term.
m
Yeah.
plus m whole square. Yeah.
Yeah, V naught square. So therefore this equals to sine theta by 2. Sine theta by 2 is equal to half small m by capital M plus small m V naught upon root over GL. So therefore theta is equal to twice sine inverse of m V naught upon twice capital M plus small m root GL. Yeah, the one modification I can make is that m plus m is approximately equal to capital M. This modification I can make. Otherwise, I guess no other modification is needed. Sine inverse of small m V naught upon 2 capital M root GL. This is the answer. Okay.
It's not there is any option or
I did not. I just made up the question. I did not give any options. Because
okay,
this kind of there was I don't have the question
okay,
with me
then.
right now, but there are similar questions in JAM. Not for this problem, but there are questions like, I'll give you an example. So imagine that you have a pendulum like this, and then there's a bullet that strikes the pendulum. Same problem. So you might be asked, what is the angle up to which the pendulum will climb? Find this angle. Very common question. So it's the same thing here. I mean, whether you have a simple pendulum, whether you have a compound pendulum, same kind of a system. You can also have a rod. We will do questions related to rod later on in rotation. A bullet comes and hits the rod. The rod starts oscillating with angular frequency omega. What is omega?
Yes, sir. I have done similar.
So वहाँ पे भी you need conservation of linear momentum, conservation of energy depends, or conservation of angular momentum depends upon the question, of course. But it's a similar kind of a question. Or you might be asked, what is the angle up to which the system is going to swing up to? So this is the process. Once you understand the process, everything else is just mathematical substitutions here and there, or making some approximations here and there to come up with the answer. I just wanted you guys to be a little familiar with these kinds of questions, that okay, this is possible. So yeah, be ready for it. Okay guys, all right, I have another class, I guess day after tomorrow or something, right?